My name is Deacon. This is the fourth paper on polyether ether ketone. So the research study I went through was in vivo evaluation of beta tricalcium phosphate containing 3D laser centered polyether ether ketone composites in pigs. So as was mentioned before, in vitro is something that's done outside of the body, whereas in vivo is something that's done within a living organism. This paper was done in published in the Journal of Bioactive and Compatible Polymers, and the scope of it was how polymer medical implants performance could be improved upon, as PEEK was already commonly used in medical implants. But the key question here was to what the potential of the rapid prototyping process of laser sintering was to produce 3D PEEK implants. So the materials used here was pure PEEK, which was actually compression molded. That was used as the control. Laser sintered PEEK with 1 weight % carbon black, which was just used to help the flow capabilities of the PEEK during the laser sintering process, and laser sintered PEEK with 1 weight % carbon black and 10 weight % beta tricalcium phosphate. Beta tricalcium phosphate is what's called an osteoconductive material that promotes the growth and adherence of bone to the implants. So these process conditions examined were the biocompatibility of implants, which was tested with a histomorphometrical evaluation, which basically just measures tissue growth. And this microscope here, this Axio light microscope, was used to evaluate that, as well as a push-out test, which evaluated the shear/fixation strength of the implants to the bones using this tensile testing machine here. So the first question was, are these implants capable of bonding to living bone without forming fibrous tissue? Fibrous tissue is basically what happens here when you have something like an implant in the body that's not necessarily not incompatible, but it's just the natural process of bone growing here, and it's not ideal because it keeps the implant from contacting the bone directly, which is what you can see here. This thin blue layer here is fibrous tissue, and these asterisks here in these pictures are the beta tricalcium phosphate. So this fibrous tissue layer keeps the implant from directly contacting the bone. Now, after 6 weeks of the implants being inside these bones, there were slight signs of inflammation, but this inflammation was gone by 12 weeks, and these implants were deemed biocompatible. Well, the implants containing the beta tricalcium phosphate were actually able to achieve some direct contact with the bone, between the bone and the implant. However, as shown here, this is the implant containing the beta tricalcium phosphate. There was still a very thin fibrous tissue layer, which led to no statistical difference between any of the 3 types of the implants, because they all still contained at least some fibrous tissue. The beta tricalcium phosphate implants contained much less fibrous tissue than the others, but it was still present. So the next question asked was, which material provides for the highest fixation strength between the implant and the bone? And as you can see here, the implants containing the beta tricalcium phosphate achieved a much higher shear strength than the other 2, and this was due directly because of the implant's contact with the bone. And the other 2 were a much poorer result because they experienced what was called fibrous encapsulation, whereas the PEEK implants with the beta tricalcium phosphate only saw a very thin fibrous tissue layer. The other 2 types were completely encapsulated by this tissue, which led to no possible direct contact between the bone and the implant. So the conclusions here were that PEEK is an ideal alternative material for bone reconstructive surgery, and the laser sintering rapid prototyping process is practical because it allows for much individual kind of really specific geometries, and that the implants containing the beta tricalcium phosphate were able to contact bone directly and achieve high shear strength due to that fixation. And my opinion on this study was it was a really good study. In my opinion, it was the first study with laser-centered peak implants and beta tricalcium phosphate in living subjects, and prove that with laser-centered peak implants, it is very advantageous to both patients and surgeons when using these implants, and also allowed for a basis to improve upon, such as how the osteoconductive interacts with the laser centering process, because the weight percent of the osteoconductive actually affects the manufacturing process. Anything much higher than what was contained in this study, which was 10 weight percent, adversely affected the manufacturing process. So this study allows another avenue to be approached as to how the laser centering process can be improved to be able to contain more of this osteoconductive material or another osteoconductive material, because that would greatly improve the contact ability between the implants and the